Welcome to our first video of 8th grade year 1.1 rational and irrational numbers. We're going to start off by just kind of going over some definitions because we may have forgotten or may not know what rational and irrational numbers are. Alright, so our first definition is a rational number. This is one we should remember. It says any number that can be written as a fraction, a over b, where a and b are integers and b is not 0. This is just a really technical way of saying any number that we can write as a fraction. We know we can write whole numbers as fractions by putting them over 1. We can write decimals as fractions by turning them into fractions. And fractions are already in fractional form. So they're all examples of rational numbers. And we have two different types of decimals that we're going to talk about here. Terminating decimals, they're decimals that come to a conclusion. That's what terminating means. They stop. They have a finite ending. And then we have repeating decimals. These are decimals that continue on in a pattern infinitely, and we have a way of showing that. And we'll talk about that in a second. So let's take a look at a couple examples. First thing we're going to do is talk about turning fractions into decimals. It says, in order to convert a fraction to a decimal, we must divide the numerator by the denominator. So we want to take the numerator and we want to drop it into our division symbol, and then we want to divide. So when we do that, we shouldn't have our number go into our other number, meaning we should have a larger number here on the outside. And that's because a fraction is less than 1. So if it went in, then it would be a mixed number and not a fraction. Okay, so 4 does not go into 1. So what I want to do is I want to put in my decimal point. I want to add a 0. And I want to move that decimal point straight up to the top. Okay, and then I just want to divide normally. 4 goes into 10 2 times. Okay, and as long as I have a remainder, I want to keep adding a 0 until it either stops, like it will in this case, because 4 goes into 20 5 times, and we have 0 as a remainder, or until you see a pattern, something repeats over and over again. That's the difference between our terminating decimals and our repeating decimals. Okay, so 1/4 as a decimal is 0.25. Take a look at the second example. Okay, this time they want us to convert the fraction 1/3 to a decimal. So again, we drop the 1 into the house, we divide the 1 by 3. 3 does not go into 1, so I add my decimal point, put in my 0, bring my decimal straight up to the top, and I divide. 3 goes into 10. 3 times. Wrote that in the wrong spot. 3 times, and 3 times 3 is 9. I keep bringing down my 0. Right now I can see I have 10 again. Well, I just had 10 before. So if I keep trying to divide by 10, it's going to go in 3 times every single time. And I'm always going to have one remainder. Bring down the 0, gives me a 10. Okay, so I know that I'm going to keep repeating in that pattern. It would end up being 0.3, 3, 3, 3, so on, all the way down the line. Okay, we write this as 0.3, and then we put a bar over our 3. And this sign indicates that that part repeats. Okay, we only put the bar over the portion of the number that repeats. So if you have a decimal that, let's say, is 0.131313, it goes over both the 1 and the 3. But if you have one that is, let's say, 1, 3, 3, 3, 3, the bar would only go over the 3 because that's the part that repeats. Okay, so we have terminating decimals, 1/4 is 0.25. Repeating decimals, 1/3 is 0.3, repeating. Take a second, pause the video, do the next section on your own, come back and we'll go over it. So let's take a look at these. First one is 4/11. So we drop the 4 into the house. We have the 11 out of the house. Put in our decimal point. 11 goes into 40 3 times. 33. We get a 7. 11 goes into 70 6 times. already I see I got a 4 again, which means that same pattern is going to repeat. It's going to go in 3 times and then 6 times, and 3 times and then 6 times. So what I have is 0.36 with a line over both the 3 and the 6 because they both repeat. Our second one, we have a mixed number, 1 and 1/5. When I get a mixed number, get rid of the whole number. Just worry about the 1/5 part at the beginning. Okay, so let's drop the 1 in the house. Let's have our 5 out of our house. Let me straighten that line back up again because that's a little sloppy. Okay, I put in my point 0. 5 goes into 10 2 times. Okay, 0 remaining. So my decimal is 0.2, and then I take my 1 and I put it right back in front of the decimal. So 1 and 1/5 converts to 1.2. And the last one is 1/8. Drop the 1 in the house. 1 divided by 8. Put in my decimal straight up to the top. Add my 0. And I divide normally. Sorry about the bad handwriting. 2 times 8 is 16. Bring another 0 down. I don't see any pattern so far. Nothing's repeated. And then 8 goes into 40 5 times. That goes in evenly. So I have my decimal as 0.125. Okay, hopefully you got those. If not, try and find where your mistake came. Okay, now we're going to go in the other direction. So we started by turning fractions into decimals. Now we're going to turn decimals into fractions. So now we're going to take decimals and turn them into fractions. It's actually a pretty easy process. Okay, we're given, for example, the decimal 0.825. Okay, what I want to do is I want to look where the decimal place ends. I want to see what the place value for that decimal is. So in this case, it ends at a 5, and that's the thousandths place in decimals. Remember, we don't have a ones place in decimals, so it goes tenths, hundredths, thousandths, millions, so on. Okay, it ends in the thousandths place. So I want to take this number, 825, and place it over 1,000. And then my goal there is just to simplify. 25 goes into both of them. So I do 825 divided by 25, which is 33. 1,000 divided by 25, which is 40. And that tells me that my simplified fraction, 4.825, is 33 over 40. So you see where the place ends. You write it over that fraction, and you simplify until you can't do anymore. Okay, so now we know how to take fractions, turn them into decimals, take decimals, turn them back into fractions. Okay. Now we're going to look at a different type of rational number, and that's called a square root. And this is something new that we haven't covered yet. So let's take a second and look at the definition of a square root. It says a square root is a number that when multiplied by itself gives another number. So for example, it's a very confusing definition, so it's easier when you actually look at the example. If I take the number 2 and I square it, so I do 2 times 2 equals 4. Okay, so that would mean that the square root of 4 is 2, because 2 is the number that when multiplied by itself gives you 4. Another example would be the square root of 9 is 3, because when I take 3, multiply it by itself, it gives me 9. The square root of 16 is 4, because 4 times 4 gives me 16, and so on and so forth. Okay, these numbers are what are referred to as perfect squares, because they have a whole number answer. Okay, so the square root of 16 is 4. That's a perfect square. Let's take a look at a couple examples. We'll solve some equations using square roots. So we have the equation x squared equals 121. You know that when we solve an equation, we do the inverse operation, so we do the opposite. Well, the opposite of squaring a number is to take the square root. So the way we solve a squared equation is by taking the square root of both sides, which you can see in that first step. So we take the square root of x squared, which is x because x times x gives me x squared. So it's actually a perfect square for x. And we take the square root of 121, 11 is the number that when squared or multiplied by itself gives you 121. Okay, there's a reason why, though, we have more than one solution. So this sign actually means plus or minus 11. Positive 11 and a negative 11 are both solutions. Okay, that's because when I do 11 times 11, I get 121. But also, if I were to do negative 11 times negative 11, I also get 121, because a negative times a negative is a positive. Okay, the positive version is generally the answer that we're looking for, and it's called the principal square root. But just be aware that there are multiple answers for square roots. Just generally, when we're asking for an answer, it's the positive version. Let's do another example. Okay, so we have in the second one, x squared is 81. Okay, so I want to first get rid of the x squared by doing the opposite of squaring it and taking the square root. So I take the square root of both sides. The square root of x squared is x, again, because x times x gives me x squared. And the square root of 81 is 9, because 9 times 9 is 81. There are always two solutions, the positive and the negative version. So my solutions are positive 9 and negative 9. So we also have a term called cube root. And cube roots and square roots are related. The difference is a cube root is a number that when multiplied to the third power gives the number intended. So instead of doing squaring it, we're going to cube it. We're going to multiply it 3 times. Okay, and let's take a look at an example here. We have x cubed equals 729. Okay, so we want to start off by doing the opposite of cubing it, which is to take the cube root. The only difference between the square root sign and the cube root sign is you put a little 3 right there in the square root sign. The cube root of x cubed is just x, because x times x times x gives you x cubed. And then we take the cube root of 729, which is 9, because if I do 9 times 9 times 9, that gives me 729. So my solution is 9. The reason why it's not positive and negative 9 is because if I do a negative times a negative, I get a positive. But then the third time I multiply a negative, it brings the number to a negative. And we're not looking for negative 729. We're looking for positive 729. So I have one solution when I'm cubing the number. Let's take a look at another example. Okay, we can easily do square and cube roots of fractions. Okay, the steps are exactly the same. I take the cube root of x cubed first, and on the other side, I take the cube root of 8 over 125. If I want to do that, I just take the cube root of the numerator and the cube root of the denominator. So this is x. I have the cube root of 8, which is 2. 2 times 2 is 4. Times 2 again is 8. The cube root of 125 is 5. 5 times 5 is 25. Multiplied by 5 again gives you 125. So therefore my cube root of that fraction is 2/5. Pause the video, try a couple on your own, come back and I will go over them. So hopefully you paused the video, came back, check your answers with mine. First one, we have a squared equation, so we're going to take the square root of both sides. Okay, so the square root of x squared is x. The square root of 196, which is 14. I do have two solutions, a positive 14 and a negative 14, but I'm just going to go with the principal square root here, or the positive version, and say my answer is 14. On the second one, which isn't numbered for some reason, I want to take the square root of both sides. Remember, when I take the square root of a fraction, I do the square root of the numerator over the square root of the denominator. The square root of 16 is 4. 4 times 4 gives me 16. The square root of 81, we've already said before, is 9. So my square root is 4/9. The third one, x cubed is 512. Sorry, I take the cube root of x cubed, which is x. I take the cube root of 512, which is 8. So therefore, the cube root of 512 is 8. As you start to see them more and more, you kind of see the patterns, or you know about where it should be because you know other cube or square roots. Let's take a look at the last one. We have the cube root of x cubed, the cube root of 64 over the cube root of 343. The cube root of x cubed is just x. The cube root of 64 is 4. 4 times 4 is 16. 16 times 4 gives you 64. And then 343, the cube root of 343 is 7. 7 times 7 is 49. And then 49 times 7 is 343. So my answer is 4/7. This is not it for section 1, but it's a long video, so I wanted to break it up into 2 parts. You can continue with rational and irrational numbers part 2 with the link below. Also, if you don't have the notes that goes along with this, you can check my Teacher Pay Teacher store, which is also in the link below. If you have any questions, please ask. Do whatever you have to do.